Hello students, welcome to my channel Engineer Ash Ma'am. In this video, I am going to solve numerical based on beam to column connection. Beam to column connection with the help of frame angle. So you can see here frame angle. This one is beam column connected by frame angles. Bolted connection. Bolted connection. Two framing angles, Indian standard angles 150 into 150 into 10 mm are used to make beam to column connection. So you can see here two framing angles. One at this left hand side and second one is right hand side. Two framing angles are used here. Size is 150 into 150 into 10 mm. ISA indicate Indian standard angle. One angle is placed on either side of the beam. So one side of this angle is connected to the wave of the beam. So this one is wave of beam, wave of beam. So one plate is connected to this wave of beam. Three bolts of 16 mm diameter used. So number of bolts are 1, 2 and 3. And diameter of bolt is 16 mm is given. And grade is 4.6 grade is given. Used to connect the angle legs to the beam. Determine the reaction. Determine the reaction R that can be transferred through the joint. Column sections ISHB 300 is given. This column section is ISHB 300 Indian Standard Heavyweight Beam 300 at the rate 618.03 Newton per meter. And beam section is given ISMB 350 at the rate 514.04 Newton per meter. You can see here it's clearly visible here, that is one plate of this frame. This one plate of this frame is connected to column's flange. So you can see here this one is column, flange of column, flange of column. Okay, so one plate of this angle, frame angle is connected to column flange. Therefore, thickness of column flange is required. Thickness of column flange, that is TF, is required. Column of column. Okay. And second one is beam section. For beam section, you can see a second plate or second side of this angle, frame angle is connected to wave of beam. Therefore, thickness of this wave is required. The thickness of wave is 8.1 mm, which is given. Or you can take this value from this scale table. These are angle sections. T sections. Or here is I sections. I sections, beam ISMB, beam ISMB 350. Beam ISMB 350. You can see here ISMB 350 is here. Beam ISMB 350. Okay. ISMB 350 and thickness of wave of beam. Thickness of wave of beam in this column. In this column or in this row, that is thickness of here. Thickness of beam. Thickness of wave of beam, which is equal to 8.1 mm. Okay, for beam. Here 8.1 mm, and second is For column section, thickness of flange is required. Column section is ISHB 300. So you can see here ISHB, ISMB. After ISMB, there will be ISWB. Next ISHB 350. So you can see here ISHB 350. There are two sections of ISHB 350. ISHB 300. Sorry, ISHB 300. So there are two sections of ISHB 300. So you can see here weight is given. Weight is 618.03 Newton per meter. 61 means second one. This is 618.0 Newton per meter is given weight. And thickness of flange. Thickness of flange, it means this column. Thickness of flange and ISHB 300, that is Indian Standard Heavyweight Beam, having weight is 618 Newton per meter. This row. This row. Therefore, thickness of flange is 10.6. Thickness of flange equal to 10.6 mm. Okay, you can see here. Thickness of flange is 10.6 for column and thickness of wave equal to 8.1 for beam. Next. What is given? Bolt grade 4.6 is given. Bolt of grade 4.6 is given. It means ultimate strength of bolt equal to 4 into 100 equal to 400 MPa. And yield strength of bolt, which is not required in these numericals, but we can calculate 400, that is 0.6 into 400 equal to 240 MPa. Okay. Next, what else is given? Diameter of bolt is given. Diameter of bolt, it is D, equal to 16 mm is given. Next, diameter of hole. Diameter of hole D naught. Okay, which is equal to D plus clearance. So D equal to 16 mm. You can see here page number 19. On page number 19 of IS 800 clause 10.2.1. Okay. So clearance is given in this table. If the diameter is varying from 16 to 20 mm, 22 mm, then we have to consider clearance of 2 mm. Okay. If it is bolt, then hole diameter will be plus 2. So with the help of table number 19, page number 73, clause number 10.2.1, we can we can take value of clearance. Okay. Therefore, clearance is 2 mm. 16 plus 2, 18 mm. Therefore, diameter of hole is 18 mm. Diameter of nominal diameter is 16 mm. Next, what else is given? Can consider partial safety factor of bolt material equal to 1.25 and ultimate strength of plate equal to 410 MPa for Fe 410 grade of steel. Grade of steel. Okay. Next. We know that this is, if it is a column, this will be a flange of column. If it is column, there will be a flange of column. Here is wave and here is beam. So angle will be connected here. Frame angles we have to connect here. Like this. Bolts 1, 2, 3, 1, 2, 3. The bolts for making frame connection of angle legs with wave of the beam will be in double shear. One at this side, other will be at other side. Same angle will be there at other side if you are seeing from this side. So one angle will be at this side and second will be at other side. Okay, it means double shear will occur. At this side, one plate, this wave is second plate, and at other side, one more plate is there. So three plates will be there. Okay, 1, 2, 3. At this side is 1, at other side is 2, and this thickness of this wave will be third one. So there are total 3 plates and bolts will be here. So if it is bolt, 3 bolts are there, 1, 2, 3. If you are considering one bolt, there is chances shear failure chances or cut number of cuts are 2 here and here. So bolt can fail at 2 points, at here or at here. Therefore, NN equal to 2. Or we can say it as double shear will occur. Double shear. Okay. The bolt for making frame angle, frame connection of angle legs with wave of the beam will be in double shear. Okay, double shear because two sides, two angles, and one is thickness of wave. Let's find strength of bolt in double shear. First is strength of bolt in double shear. We know that formula is VDSB equal to FUB upon root 3 gamma MB NN into ANB. So here FUB, ultimate strength of bolt, is 400 root 3. Partial safety factor for material of bolt is 1.25. Number of cuts are 2 because shear failure may occur at 2 sections and net area will be 0.78 times diameter of bolt, and diameter of bolt is 16 square. Okay, into 10 raised to minus 3 or kilonewton. So we'll get answer of PDSB equal to 58 kilonewton. Therefore, double shear strength of bolt in double shear is 58 kilonewton. Okay. Next is second, strength of bolt in bearing. Strength of bolt in bearing. So at page number, you can see 75, formula is given. Page number 75, clause 10.3.4. Here you can see shear capacity of bolt. Shear capacity of bolt formula is given, which is equal to VDSB equal to VNSB upon gamma MB, where VNSB is FU root 3 NN ANB plus NS ASB, where we neglect NS or ASB, we consider it as 0 because we consider that our bolt is felt in threaded area, not in shank area. Okay. And second formula is bearing capacity of bolt. Bearing capacity of bolt VDPB equal to VNPB upon gamma MB, where VNPB is 2.5 kb dt FU, where kb is smaller of these four. Okay, so let's solve next value. Strength of bolt in bearing. That is page number 75 of IS 800. IS 800. PD PB equal to 2.5 kb dt FU upon gamma MB. Okay, 2.5, where kb is, next is d is diameter is 16 mm. Ultimate strength of plate is a 410 MPa. Gamma MB is 1.25. kb we can calculate, and next is T. T should be smaller out of all plates. So we know that thickness of wave equal to what? Thickness of weight is 8.1 mm. Thickness of wave is 8.1 mm, and thickness of angle is 10 mm. Consider minimum thickness is 8.1. So out of these three plates, thickness of this wave is 8.1 mm. Okay, thickness of this angle plate is 10 mm, and thickness of this frame angle is 10 mm. So 10 plus 10 is 20, and here is 8.1 mm. Then a weaker plate will be 8.1, or in bearing this plate will fail first in bearing. Okay, therefore consider thickness equal to 8.1 mm. Here, thickness minimum of angle thickness and thickness of wave of beam. Okay, therefore minimum is 8.1 mm. Therefore adopt thickness equal to 8.1 mm. Next is kb. kb is smaller of four values. 1, 2, 3, 4. 1, 2, 3, 4. And see here in IS code values are given, that is E is smaller of E upon 3D0 or P upon 3D0 minus 0.25, FEB upon FU up and 1. Okay. First one is KB equal to E upon 3D0. Okay. Second one is P upon 3D0 minus 0.25. Third one is FU P upon FU plate or 1. But E or P is not given. You can calculate E. E is edge distance or end distance, which is equal to 1.5 times diameter of hole. 1.5 times diameter of hole is 18. So we can round up it as a 40 mm. Okay, on higher side. You can take any value greater than 1.5 into 18. And next is pitch. Pitch P. So pitch should be greater than 2.5 times diameter, nominal diameter. So we know that 2.5, nominal diameter is 18. This value we can consider higher side. So it comes out to be near about 50. So we are going on higher side. So P will be 65 mm. You can assume 60 mm, 65 mm, 70 mm, etc. Go for higher side. Okay. Formula of this E and P is already given in our school. You can see here minimum spacing, that is pitch should not be less than 2.5 times the nominal diameter. It means pitch should not be less than 2.5 times nominal diameter, or P should be greater than 2.5 times nominal diameter. Okay. And age and end distance clause is here, somewhere here. Age and end distance clause is here, 10.2.4. So it should be 1.5 times the whole diameter in case of roll sections. Okay. So end distance should be greater than 1.5 times the whole diameter, that is equal to 1.5 times whole diameter. Where E is now 40 upon 3, diameter of hole is 18, which is equal to 0.74. P is pitch 65, you can assume 60 also, or in distance you can assume 35. It's a design question, so values can be variable, can vary student to student. Go for higher side always, just for factor of safety. Okay. D naught is 18. Okay, diameter of hole minus 0.25, which come out to 0.95. Next is FPB, ultimate strength of bolt is 400, and we know the ultimate strength of plate is 410, which is equal to 0.975, and last one is 1. So out of this 4, minimum value is 0.74. Therefore, adopt KB equal to 0.74. Now substitute this all values in equation. Strength of bolt in bearing. Strength of bolt in bearing of bearing on web of film. On web of film. Okay. We know that formula is VD PB equal to 2.5 KB dt FU upon gamma MB. Okay. Substitute all values. 2.5 as it is. KB is minimum, that is 0.74. Diameter, this is the diameter. Diameter is 16 into, this is thickness, and thickness is minimum thickness 8.1 into ultimate strength of plate 410. For kilonewton, you can multiply it by 10 raised to minus 3. Okay. Upon factor of safety of bolt material is 1.25, which is equal to 78.64 kilonewton. Okay. Strength of bolt in bearing. The strength of bolt in shearing or in shear is VDSP equal to 58 kilonewton, and second, in bearing strength is VDPB equal to 78.64 kilonewton. It means if load is less than 58 kilonewton, then this load can easily bolt can safely can take this load. If it is cross 58 kilonewton, then bolt will fail in shear. Okay, if load is cross 58 kilonewton, then bolt will fail in shear. Therefore, strength of bolt equal to, or bolt value, or VD equal to minimum of the shearing and bearing strength, that is VDSB and VDPB. So minimum is 58 kilonewton. 58 kilonewton. Okay. So it means since three bolts have been provided, since three bolts have been provided, maximum end reaction that can be transferred equal to number of volts into bolt value. Bolt value. You know that number of volts are 3 and bolt value is 58. Therefore, 174 kilonewton. Reaction equal to 174 kilonewton. Okay. Thank you for watching. To like, share. Subscribe.